object, same class, if they comply, and we treat them as such, then we'll be able to have things that are side by side. For instance, let's say that you have an animal interface, right? So the animal interface, let's say that you can ask how many legs do you have, or speak. What is your language? Speak. And then you have, say, a duck that actually implements that interface. So whenever you say how many legs, it will return 2. And you say speak, you say quack. Right? For you cat lovers, let's say you have a cat. So if you have a cat, you say how many legs do you have? Well, 4. Speak. Meow. You see? Now, I could have done that by creating a superclass, right? That would be the call. We say, well, yeah, we will create a superclass, which is called animal. And then we will override everything in there. We'll actually make the superclass animal a virtual or an abstract class. Sorry, virtual is in C++. But make it an abstract class. Yeah. Except that now every animal has to be a subclass of animal. Everything that you create. But if you make it an interface, it's flexible. I don't have to have anything in the hierarchy. I can create anything that implements that interface. All right, so let's create here for our student. We will create an interface. So keyword interface, and now I'm going to call this iStudent, and the iStudent is going to have, let's see, which are the ones that we have in here. First name, last name, age, and full name, right? Not credit hours. Okay, the way that we do that by creating, making them properties, it will be string, first name, set, get, string, class, name, set, get, string, full name. We now have a setter and a getter. And we also have int, age, set, get. And what was the other one? Credit hours. Credit hours, set. I think that's it, right? These are the ones that we have here. Oh, we have class as well. The class. And this one will return, what was it, year? Year. But we only have a getter, right? Remember that was a read-only, and the getter is actually you're grabbing that. You're only getting we're only getting the information based on the number of hours. So we never set it. It is again a computed property. So now that we have this is my contract, my template, my interface, my protocol, and this is I want anything that I want to treat it as a I student, I'm using the I in there for interface student. I wanted to implement that, and as long as I have something like that, it doesn't matter what class I use. If it complies with that, then I'm good. I can create anything that will simulate a student this way. Okay, so in order for this to make it comply with that, we would say I student. Let's do a build. Succeeded, So I put everything that is in the interface being implemented by students, so it is okay. If I were to not implement one of those, then it will give me an error and say, but I'm sure that you've done that in Java, so that should not be new. The only difference is in terms of the syntax. Instead of using the colon right here, what do you use in Java?
Is there a
Implements, right? Here we use exactly the same for implements and extends. If you want to make a subclass, of a class, you also use the colon, exactly the same. Okay, so now we can come back up here and we can say that, we will have something like this. And let's see if this one will run. Right? Same thing. Yeah, we're gonna return back to our Smith, John. Right? So why is it not working? Right, it's not working.
You need to get rid of the space. It's taking the commas and spaces each produce a new thing.
Oh, okay, so we need to remove the space from that?
Yeah.
All right, so to solve that, what do we do? Anybody knows? Wayne, you're my only hope. What do we do? The reason I say is that maybe you've used it, or maybe somebody else has used it. Because this happens a lot, you end up with a space but you don't want it, and et cetera. You know what's going on in here? Why is it that I lost one of those, right? You see how I lost, let's see. I got Smith, but I don't have the first name. In fact, first name is a space. You see that? See how when it says the full name is space Smith. So my first name became a space.
If you get rid of this, go back to the code where you do the separate strings. If you just get rid of the space and the comma, that would figure it out. Not the like the
This one
space
here?
yeah, that space right there.
Okay.
Well, almost.
What?
Oh wait, I thought the third one was full name. Sorry.
Yeah, but what? I mean, it worked.
No, I just tested it. And see if it worked.
You hacked it.
Oh.
When you just try something, see if it sticks, See, once you do that, if you find this, why did it work? Because I hear this a lot. I don't know why
I
it
just
worked.
hacked it and I just had a thought because I've been messing with it while you were talking about your wrong name. It's like there's gotta be something.
It is good, but you need to
I guess
know
it's
why.
because we already have something for the space split, or because we already set the first name. I'm not really sure. I haven't really looked much at the split this part, so I just.
So if I just add that, I lose the first name.
It's because
Right.
at the top,
Say again?
have to like go back to Floyd, scroll all the way to the top, all the way to the top. I think it's because you have the comma and then you have the space.
Well, I see, that's, it's one of my formats, so it should be able to pick it up.
So, if I had to guess, the reason it's working differently is because when you use the delimiter, it finds the comma and says, okay, the second entry in the array starts with the following character, and then, but doesn't go any further than the next delimiter, which is that same character. That'd be why it would use the space.
It's a good guess. I mean, that's what's happening, is I'm actually using two separate, separators, sorry, that's fine.
I'm wondering if a solution could be, if you go to the array that's created and delete any entries.
Oh, sorry. It's just telling me that it's tolerable for, anyway. Yes,
Could we go to the array that's created and just delete any empty entries? So then John, instead of being, the third entry would be the second?
right. And so if I were to put no space, for instance, if I don't put a space, like here, right, I eliminated the space, now it's acted correctly. See, this is where we need to sort of check for something like this and see, for instance, what will this do when you actually have something like this? How does it behave when it has two separate separators, right? How does it behave? I'm going to write in here and say, right line, the number of tokens is was separator strings, actually it should be named differently, length, right? So let's take a look at it.
Console. Usually
Oh yeah,
console.
console, sorry. The number of tokens is 2. So the length, oh, no, wait a minute, that's not the one that I wanted to ask for. Here, and it's actually parse string. That. It says 3 tokens. What are the tokens?
First name, last name, last name, so first name.
First name, second
space.
token is a space, the third token is, first name actually, last name. Why did it like that? Cause it's used the first separator, which is a comma, right?
The next one is the space.
And then the space actually at that point was taken as a token. So that's why you have space, and that's why we say John Smith, then John disappears. Because now you don't have really John, you have space, 1 token, and John, the other token. Yeah, you should do this, because as you pointed out, it has a space.
I mean, like, how we have in the code underneath it, like, first name is first name, and the last name is first name.
Yeah, because as I said, we're taking.
Should we put something, maybe we should make, something for the middle value, just in case?
Let me show you, something in here. This, you deal with a lot of these kinds of issues whenever you're dealing with strings, and we deal with strings in many, many places. So here, I'm going to put, this is the number of tokens, and I'm gonna do this. See if it comes out. This will be plus, I'm just gonna do first name. Okay? I'm gonna do this, that's the one that we're missing, right? First name is, and we're gonna move that from there, here. Right? So after we set it, we're actually gonna, so this is the first name. In this case, first name is empty. Yes, okay, now we're gonna do your suggestions, which is we remove this as a separator. Now your first name is space John. So now we, by removing the space as a separator, we are now considering space as part of the word. And now we have a leading space into John. So how do we eliminate that? Remember that the first thing that we were gonna do was gonna find out how many tokens we had, et cetera, how many pieces. But how do we eliminate that quick? That's what I was hoping that, maybe Wayne had used something like that. Trim. Trim is a function, whenever you find something like this, let me go back to my documentation, and then you will find that there is a particular one. Did I miss it? Yes. Trim. You will find it everywhere. Okay, actually that comes, I remember, from Basic, and you will find it in Visual Basic. And it's a trim. There used to be one that was called left trim, no, that was L trim, R trim, and trim, which actually trims. It removes extra white spaces from beginning and ending of the string. So if I now if I were to use just this one as a separator, but then in here I say first name, dot trim, oops. And then this one, just to make sure. It's gone. So trim is something that you might want to use whenever you're splitting, by spaces, and then you might have extra spaces, etc. For instance, I could have written extra spaces at the beginning of the last name, space, 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 or tab, 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 some other things, that's part of white space, and then it will introduce that and actually have tabs or spaces in the first name. Something like this actually eliminates, that's something that we do a lot. So trim will eliminate white space, which includes more than a space, at the beginning and at the end of the string. All right, so this will take care of that, but we still need to do, we will need to do counting of those, to make sure that you don't have extra, extra words, etc. To make it, in such a way that it will be more robust. Okay, so I'm going to comment this out. And coming back to this, we have iStudent, equals to student, go back to the other thing. And right here, by just creating iStudent, see, we have an interface object. Now, I could have another kind of object that actually also implements the iStudent and then set it to that one. And it will take it, right? Just like a regular interface that you've used in Java. As I said, I don't know how many times you've used it. If you took data structure with me, you probably were sick of using it, maybe. Right, Kyle? Not so much, but you use it, you know. When you create those things, you will see, you know, the difference that makes. We will see later on. I know that you've heard that to solve these kinds of problems, you know, sometimes when you're creating things, objects that are sort of similar, sometimes you would actually make them subclasses. Good object-oriented design actually calls for minimizing subclassing. So this is sort of counter whatever you've learned. So, oh my God, we can create this class over here, and then we make a subclass and a subclass and another subclass, and then you end up with a tree. You know, it's a Christmas tree all full of subclasses. That is actually not a good practice with good object-oriented design. In fact, object-oriented design calls more for interfaces, you know, instead of subclassing. We'll look at that. And we'll take a look at the principles that we want to maintain when we're doing object-oriented design. All right, I'll post this code, and I'll see you